Okay, Math 1301. For Math 1301, this is our online class for Friday. I'm going to post this to my YouTube channel, and the link I'll send to everyone through Blackboard. What we want to do is work a problem that relates to the normal curve problems that we did in class on Wednesday. But I want to do one problem, but with 4 parts. And these 4 parts, this entire problem involves average compensation. So we're going to talk about average compensation for school teachers in Texas, for first-year school teachers in Texas. I'm making this problem up, okay? So this is not some data I got from somewhere. I'm just making it up. So let's suppose, though, we have the average compensation for first-year teachers. Okay, so that's what we're talking about. And our mean is $50,000. So let's suppose that's our mean. And our standard deviation, which can be written as a sigma, is, let's suppose it's 4,000. Okay, so that's our data sets. And what we want to do now is, if you remember on the normal curve, what this would mean is that the normal curve, which is shaped like this, that this center point here is the 50,000. And that the z factor plus 1 standard deviation above, that's 54,000. And 1 standard deviation below, a z factor of -1, is 46,000. And then if we go to +2, this is 58,000. And if you go to -2, this would be 42,000. And the idea behind the normal curve is that half of the data is below the mean, half the data is above the mean. And so if you ask the question, what's the probability of a first-year teacher in the state of Texas getting exactly $50,000 or less, getting 50,000 or less, the answer is 50% chance, because half the data, or 50% probability, because half the data is below 50,000. And if you said, what's the probability of getting 50,000 or more? And the answer would be 50%, because half of the data points are 50,000 and above. And so this is a normal curve. And what we want to ask is a couple of questions. One is, the first question is this: what is the probability? So question 1, what is the probability of making 56,000 or less? Now 56,000, what we want to do, first of all, these z factors, we need to find, so this is 0, +1, +2, -1, -2. These are standard deviations above and below the mean. And so if we want to find the z for this one, we would say z is equal to the number 56,000 minus the mean, 50,000, divided by the standard deviation, which in this case is 4,000. And the sign is really important, because in the chart, there's plus and minuses in the chart. And so the sign here is really important. And so if you do all this, you get 6,000 divided by 4,000. This is 1.5, and it's a positive 1.5. And so 1.5, and so what we're going to do now is we're going to look up a plus 1.5 in our table. So in our table, we see that a plus 1.5, so we go to the table and we find the positive. See, the negatives are on this page, but we have a positive plus 1.5. So this says that at 1.5, we have 0.9332. So the value from the chart, or from the table is 0.9332, or 93.32%. So that's from the table. And so if you say, what's the probability of making 56,000 or less? The answer is that, so that's a number in here. That number would be right there, 1 plus 1.5. That's their z factor. And the table value gives us all of these people. So from here, 1.5 z factor, or 56,000 and below, gives us from there below. The probability of being in this huge region here is 93% of our data is in this region here. All right, let's try another one. Number 2, what is the probability of making 60,000 or more? All right, so that's a little bit different. So the 60,000 or more, what we have here then is we're gonna get the z factor again. So our z is equal to 60,000 minus 50,000 divided by 4,000 is now equal to, so that's 10,000 divided by 4. This is 2.5, and this is a positive z. So 2.5, that's way out here. That's out here. This is the plus 2.5. Now the table, 2.5, it's going to be a huge number. So we look on the table at 2.5 and we see it's 99.38. So from the table value here is 99.38%. All right, so now that tells us the probability of making, this is 60,000 or less, but we're asked about 60,000 or more. And so this tells us the probability of making less. So to find the probability of making more is, this whole thing sums to 100%. So if 99% of them are on this side, that means the rest of it is out here. And so to find the answer to this, we'll do 1 minus 0.9938, which will give us 0.0062, or 0.62%. So that's the answer to that one, is 0.62%. So a first-year teacher making more than 60,000, something must be going on there. Maybe they have a master's degree, maybe they have some special training, maybe they're bilingual and are also high school math teachers or something. There's a bunch of things that might make their maybe they have some other particular experiences that may make them more valuable, but they'd be a very unique first-year teacher according to this set of data. Okay, so that's the first two. Now what we're going to do is turn this more into a projection and ask the question, what if we were to hire 100 new teachers? How many of them would we guess would be making a certain compensation? Okay, so we use the same data set. And what we want to do is ask this question. Let's suppose we're going to hire 100 teachers in the state of Texas. Let's suppose they have a hiring rush. They're going to hire 100 teachers. And based on our data set here, a mean of 50,000, a standard deviation of 4,000. So question 3 is about, this is a guess, how many will make 58,000 or more. Okay, so 58,000 or more. So this is this plus 2z. So this group is this tail way out here. So how many of those 100 would we expect? So what we got to do is find what's the probability and then multiply it by our 100 teachers that we've hired. All right, so 58,000 or more. We're gonna need a z factor. So we're gonna take 58,000. So this is z is equal to minus 50,000, all divided by 4,000. If you do the math on that, so put in your calculator, 58,000 minus 50,000 divided by 4,000, you'll get a positive 2.0. Okay, so now we're going to go back to our table again, and the value for 2.0 is 9772. 9772. So the table gives us 0.9772. Now we're asking, that's the probability, so 97.72%. make 58,000 or less. But we're asked for more, so we need to subtract 1 from that. So 1 minus 0.9772 is equal to, and then you can pull it off the table, of 0.0228 or 0.228%, or sorry, 2.28%. So there's our percentage, but we're asked, well, if we hire 100 teachers, about how many of them we expect to make out of these new teachers to make 58,000 or more, and the answer is we're going to take 100 times the 0.0228, and the answer is about 2 of those teachers will make above 58,000. Okay? All right, so then number 4, the question number 4 is we want to know of these 100 teachers, how many will make less than 45,000? All right, so that's our question now. How many would make less than 45,000? All right, so what we want to do with this part of it here is we want to calculate the z-factor. So this is 45,000 minus 50,000 divided by 4,000. And if you do that, you're going to get 5 divided by 4. So 5 divided by 4. And so you can put in the calculator and you'll find that this is 1.25, only it's a negative. This is a minus 1.25. So we have 45,000 minus 50,000. That's minus 5,000 divided by 4,000 is, put it in the calculator, 5,000 divided by 4,000, that will give you 1.25. So a minus 1.25. So we're going to look on our table now. And here on our table, what we're going to see is that a minus 1.25. So minus 1.2 is there. And then to get to the 0.5, we have to go up here on the top, get out to that level. So 1.25, that looks like 1056. So from the table, we're going to get 0.1056. And so 10.5%. And so we multiply that then by 1,000, by 100 for the 100 teachers, and the answer is about 10 teachers. If we hire 100 new teachers, about 10 of them will be hired at a salary of $45,000 or less based on this set of data. Now again, I'm not saying this is what Texas does. I made this stuff up. But if you have a $50,000 mean and we have a $4,000 standard deviation, the probability of being below 45,000, so that's right in here, 45,000 is right there, and this is a minus 1.25, which we calculated here, right? It's minus 1.25. Then I look it up on the table, and from the table, I get this, 0.1056. So that's my probability of making less than that, but I've got 100 teachers, so I'm going to estimate about how many of those teachers then would I expect to make less than 45,000. The answer is about 10. That's 10.5, but you could round up, you could say about 11, you could just say at least 10 or something like that. It's an estimate. And so you're going to approximate and say about 10, just like here's about 2, we would expect to make more than 58,000. And about 10 to make less than 45,000. And so this is an example of how the normal curve can function to project future information. So you figure out how the data is distributed. You say, what's the probability of something happening? And you go, well, if we have 100 people or 10,000 people coming into the system, what portion of those people, how many of those people will we expect to be at certain levels? And so you can do this with the SAT. Here's our distribution of the SAT scores. 1,000 students are going to take the SAT on Saturday. how many of those would we expect to make 600 or more on the math test, or 500 or less on the math test? And what you could do is then you set up your normal curve, normal distribution, you calculate your z-factor, the value you're looking for minus the mean divided by the standard deviation. You'll get that formula on the test, but you should practice with it. And then from that, you get the z-factor and you look it up. But just again, remember, you got to know, is this positive or negative? If this value we're looking for is less than the mean, you're going to get a negative number here, and you need to pull from the negative table like we did down here. If you get a number bigger than the mean, you're going to get a positive number. See, 58,000 is bigger than the mean of 50,000. You're going to get a positive number here, and you pull from the table on the right side. Now, I'm going to give you the table, obviously, on the test. But you have to know whether you're pulling from negative or positive, and you have to know what the table tells you. The table tells you the probability from that spot, wherever it is, -1, -1.25, plus 1.5, whatever, from that spot this way, the probability of being below that amount, So anytime you ask the question about something more than, then you have to use, you have to subtract that percentage from the 1 or from 100%. This whole thing is 100%. You have to subtract that from 100% so that you can find what's left out here in this end of it. All right, now there's one more trick to all this, and I will show that to you on Monday when we do our practice test. So I'm just letting you know there's one more trick, and we need to look through the issue. What if I'm trying to find something between two numbers, like between there and there? How do I find this? What's the probability of being between 46,000 and 58,000, for instance? And the answer there is we're going to pull from this one, and then we're going to subtract this to get the difference between the two. And I'll show you that method on Monday in person, but you do need to know how to do these 4 types of problems I showed you today, how to find the probability, and then how to apply it to a sample data set of like 100 teachers or 1,000 teachers or whatever the question might be. All right, well, I hope you guys have a great weekend. I'll post this to our Blackboard discussion area. I'll email it to everyone, and I'll put it on my Mansfield Knights baseball page so you can get to it there. All right, God bless you guys. Have a good weekend.